that holds together two pieces of other chromosomes. Let's see if we can do that. Now, how would we recognize that? Well, a biology student will tell you it's much easier than you might think, and here's why. Chromosomes have at their tips special DNA sequences called telomeres, only found at the tip. Near the center, they have special sequences called centromeres. If in the lineage leading to us, two primate chromosomes got stuck together, you know what you'd have? You'd have a chromosome with telomeres in the middle, where they don't belong. And you would also have a chromosome with two centromeres. So that's what we're looking for. So now we're going to look at the human genome and see, do we have a chromosome with telomeres in the center and two centromeres? And if we don't have it, this common ancestry thing might not be true. Well, it turns out we do. It's chromosome number 2. And this is a paper published last year in Nature showing that our human chromosome, let me read you from the paper, even though it's sort of technical. Chromosome 2 is unique to the human lineage of evolution. It emerged as a result of head-to-head fusion of two chromosomes that are still separate in other primates. We know the precise fusion site. It's at base 114,455,823. We know the exact base pair where the Scotch tape is hanging out. We've got the extra telomeres right here, and lo and behold, there are two centromeres. One of them is inactivated. The inactivated one corresponds to chimp chromosome 13. The active one corresponds to chimp chromosome 12. What does this mean? It means that we are descended from common ancestors with the other great apes that had 48 chromosomes, and we can see that lineage in chromosome number 2 where the fusion points come together. Is there any way to interpret this factual data as being evidence for an intelligent designer or the spontaneous creation of our species out of nothing? The answer to that is no, unless you're willing to think of a designer who wanted to fool us by giving us a chromosome that only looked like it had been descended by pasting these two guys together. And if you want to believe in a super force that is so deceptive, we'll go ahead and do it, but it certainly isn't a scientific point of view. Now, what I'd like to do right now is to take a break, answer a few questions, and after you guys get an opportunity to ask a few questions, basically I want to tell you about what happened in that courtroom in the trial that began a year ago yesterday. Thanks a lot, and I look forward to your questions. Don't forget, we have substantial bribes, and if no hands go up, I'm taking them all home. Okay. You, sir, an orange shirt.
How does the evolutionist theory fit in with your religion?
Ah, okay. You ask sort of the big question, which is, how does the evolutionist theory fit in with my religion? I think it fits in extremely well, and what I'd like to do, if you don't mind, is to sort of defer that a little bit. And at the end of the lecture, if you're still interested in that, I'll show you another clip from the Stephen Colbert show in which he asked the religious question. But the way I would put it is this way. What evolution tells us is that our species has a natural origin. In other words, we come out of the same process of nature and everything else. Well, if you read Scripture, Genesis tells us you are made out of the dust of the earth. Well, that's what evolution tells us too. In other words, we have a lowly origin. And in the Western scriptural tradition, God or Allah reminds us of that constantly, that we are made out of the dust of the earth. That's what evolution says as well. Having a natural process to account for our origins, to me, is no more theologically threatening than realizing that the phases of the moon or the apparent movement of the sun are natural processes as well, even though in olden times people attributed those to the direct action of God. So I don't want to get into detailed theology, but in a general way, the problem, theologically, as far as I'm concerned, was solved by Thomas Aquinas in the 13th century. And Aquinas, who was one of the great Christian writers, his great insight was that God, if he exists, is the cause of causes. So showing that something has a natural cause doesn't take it out of the overall plan of that divine force. And to me, that's how evolution fits in. I can talk more about that later if you want. The right-hand corner, all the way over here. Yeah.
When you were talking about the chimpanzee, you said that their chromosomes that fused together was 12 and 13. But when you were talking about the humans, you said that the fused one was in 2. How did it skip up to number 2?
Well, the answer is, don't forget, we're the human beings, so we're the guys who do the numbering. Okay? And we number human chromosomes. Number 1's the biggest. Number 2 is a little smaller, number 3, number 4. So we numbered them by size. We actually made a mistake. The smallest human chromosome is 21, but 22 looks smaller to the first people who did the numbering, so we got those numbers messed up. The primate chromosomes have been numbered exactly the same way. So chimp, and for that matter gorilla and orang chromosomes 12 and 13 are the 13th and the 12th smallest. When they were fused together, they became bigger, right? So that's why the number changed. And when this work was done, primate geneticists all of a sudden realized the chromosomes we've been calling in other primates, 12 and 13, don't correspond to 12 and 13 in human beings. They correspond to the 2 parts of number 2. So in the Chimpanzee Genome Project, geneticists have now renamed the chimpanzee chromosomes. So what used to be called 12 and 13 are now called 2A and 2B. That way they line up, because the genes line up in a dramatic fashion with the genes on human chromosome number 2. So retrospectively, after that paper, we've changed the numbering system. Other question? Right in the back.
Is it possible that our human species is evolving or will evolve in the next future?
That's a good question, and it's one I hear a lot. Are we still evolving? Well, here's what you need for evolution to take place. 2 things. One is you need variation within a species. Okay, look around. We've got one species in here. There's a lot of variation: height, weight, hair color, skin color, eye color, blood type. So we have plenty of variation in our species. And the second thing you need is differential reproductive success, meaning some people will leave more children than others. This will tell you exactly how old I am. In a couple weeks, I'm going to go to my 40th high school reunion. And I've been emailing and corresponding with some of my old high school classmates. I have 2 kids. A couple of my friends have 3. I've found over the internet a couple who have none, and one of my classmates has 12. That is what I would call differential reproductive success. And what that means is we've got variation, we've got differential reproductive success. That's all you need for evolution. Now, can I predict where evolution is taking us? The answer is no. Evolution is an inherently unpredictable process, but evolution clearly is going to continue on our species, even though science has enabled us to sort of manipulate our own evolution to some extent, and I wouldn't be so bold as to predict how that will end up, but evolution is clearly going to continue. Okay, let's see, where's the young lady right here?
Do you think it is likely that eventually another species will come to be the dominant species instead of humans?
That's a good question. In other words, how long are we going to occupy this planet? I grew up in the 1950s, and when I went to school, we had air raid drills. And we had to go under our desks and duck and cover because we thought the Russians were going to come over and bomb us any moment. And therefore, in popular fiction, even on television, people speculated about our species through nuclear war, bombing ourselves into extinction. Unfortunately, that's still a possibility. Let me speak, however, strictly, not as a politician, but strictly as a biologist. The average duration for a mammalian species, for a mammal, in the fossil record, according to a paleontologist at the University of Chicago named Jack Sepkoski, is 2.6 million years. Our species has been on this planet, depending on when you trace the ancestry of our species, probably about a million and a half years. So far, we've got about 1 million years to go to reach the average length of a mammalian species. But that same study of the fossil record says that no mammal species has survived unchanged for more than 5 or 6 million years. So as a biologist, what I would say is the way of all species is emergence through evolution and extinction. Might that occur to us? It might. I have a feeling you and I will not live to see it, but predicting the future, except by reference to the fossil record, is always pretty dangerous. Okay, right there.
You said before that about the chromosome that's inactive in humans.
I don't think I said anything about an inactive chromosome.
Well, about the fused chromosome.
Right. Mm-hmm.
Right, sorry. And what part did that play in our development?
The answer might surprise you. Probably none. And the reason for that is we can study chromosome fusions, which occur all the time, in laboratory mice, in fruit flies, and Drosophila, and other organisms. And for the most part, the fusing of 2 chromosomes together doesn't have a very profound genetic effect. So the fusing of primate chromosomes 12 and 13 to produce human chromosome number 2 probably had very little to do with what makes